So, we've been introduced to two triangles that we must learn. So now I want to show you a problem that involves them. So this is taken from an exam paper. Using appropriate triangles, show that tan of 45 degrees is 1 and tan of 30 degrees is 1 over root 3. The appropriate triangles are these ones here. So we would need to make sure that we can draw them. Now, from this, what we can then look for is, well, if I want tan of 45, I look for 45 degrees, okay? And I could go for either of those two, so I'll go for this one. Now, tan, using SOHCAHTOA, tan of an angle is opposite over adjacent. So tan of 45 is equal to the opposite, 1, over the adjacent, 1. And so tan of 45 degrees is equal to 1. For tan of 30, I look for the 30 degrees. There it is. So tan of 30 is the opposite, which is 1, over the adjacent, which is root 3. Okay? And so you can show that these are true by using these triangles. And that's what they were there for, essentially. That's what they're there to do. Okay? They're there in order for us to find exact forms of sine, cosine, or tangent of 30, 60, or 45 degrees. Now, as for this bit, hence show that tan of 75 degrees is 2 plus root 3, what I'm doing here is letting you into something that is coming up in later videos. Okay? So, in later videos, we're introduced to the double angle formulas. Okay? And if you get your MEI formula booklet, okay, and you look at what page are we going for here? Should have had it ready, shouldn't I? There we are, page 3. Okay, page 3 on the left-hand side says, round about near the top, that tan of theta plus or minus phi is equal to tan theta plus or minus tan phi over 1 minus plus tan theta tan phi. Now, this is coming right out of the blue, okay, as something that looks particularly strange. Okay? Now, all I want to do is show you how it can be used in this problem and why we will want to have these triangles. So tan of theta plus phi, okay, if I take theta to be 30 degrees and phi to be 45, then tan of theta plus phi is 30 plus 45, which makes the 75 degrees, okay? So that's the bit there. Now tan of theta is tan of 30, okay? So tan 30 plus, because there was a plus there, there is a plus there, but that will make that a minus, so plus plus minus, tan of 45 over 1 minus tan of 30 times tan of 45. Now tan of 30 was 1 over root 3 plus tan of 45, which was 1, divided by 1 minus tan of 30 times tan of 45. Okay? Now, multiplying by 1 down here isn't going to do anything, so I can get rid of that. Don't worry about that. So I've got 1 over root 3 plus 1 divided by 1 minus 1 over root 3. Okay? Now, in order to get rid of these root 3's that are in the denominator, I'm going to multiply top and bottom of the fraction by root 3. So 1 over root 3 times root 3 is just 1, plus 1 times root 3, divided by root 3, take away 1. So what I've done is I've multiplied each of the elements in the top and bottom by root 3. I now have what appears to be a core 1 surds problem, because now I can rationalise the denominator by multiplying top and bottom by root 3 plus 1. So remember, from core 1, you multiply numerator and denominator by this, but with the sign in the middle changed. So we have 1 plus root 3 times root 3 plus 1. So 1 times root 3 is root 3. 1 times 1. Root 3 times root 3, that's 3. Root 3 times 1. Over. Root 3 times root 3, that's 3. The root 3 times 1 and the minus 1 times root 3 will cancel. Minus 1 times 1 is minus 1. So we have 1 plus 3 is 4, plus 2 lots of root 3, over 2. And this simplifies, because 4 divided by 2 is 2. 2 root 3 divided by 2 is just root 3. So that is us showing that tan of 75 is 2 plus root 3. So it's quite a laborious process, that. And I'm giving you information that we'll be looking at later on in these videos. But I wanted to link it back to using these triangles, okay? And the importance that I'm putting on remembering them. So make sure that you learn them. So keep drawing them out. Keep drawing them out over and over and over again until you can't get them wrong.